Hi, so what we're investigating today is the effects of using multiple loopback addresses for BGP address families. In other words, using one loopback address for address family IPv4 and another for VPNv4, for instance. So what I have here is I have a router 1 and router 2 connect to each other back-to-back Ethernets, but two of them. And I have loopback 1 with 21, 21, 21, 21, and 2 with 22, 22, 22, 22 on router 2. This side it is, not that it matters for this one, but 1, 1, 1, 1 on loopback 1, and 2, 2, 2, 2 oh, sorry, 1, 2, 1, 2, 1, 2, 1, 2 for router 1's loopback 2. Now I have some. I have an IPv4 session set up to router 2's loopback 1 and a VPNv4 session set up to loopback 2 on router 2. So on router 2 I have, so what we want to investigate is traffic engineering tunnels in this scenario. You will see that on router 2 I have used loopback 1 as the router ID for my traffic engineering. So let's say we want IPv4 traffic to go over fast Ethernet 00 and VPNv4 traffic to go over fast Ethernet 10, and we want to do this with MPLS traffic engineering. You'll see I have my two Ethernets. It's 10.0.12.1, 10.0.21.1 on router 1 and .2 is on router 2. So I have two explicit paths. I have my path called 00, which uses 2, and my path called 10 that uses the second link. And now I have my two engineering tunnels, show run in tunnel 0 and show run in tunnel 1. Now you'll see what I did here is I used the destination of loopback 1 on router 2 for the first tunnel and loopback 2 on router 2 for the second tunnel. But the tunnel does not, well, second tunnel does not come up, of course. It is down because the tunnel destination has to be the MPLS traffic engineering router ID, which on this side is loopback 1. So if we change my tunnel destination to be 21, 21, 21, loopback 1, tunnel should come up, and now there it goes. So there are multiple ways to force traffic down a tunnel. We don't want all the traffic to go down tunnel 1. We only want VPNv4 traffic to go down tunnel 1. So if we use autoroute announce, for instance, let's just first have a look here. I have a loopback 10 with 10, 10, 10, 10 and a loopback 110 that is inside a VRF, also 10, 10, 10, 10. If we look without any traffic engineering, how do we route to 10, 10, 10, 10 in IPv4? Of course, loopback 1 is the next stop, and if we have a look, how do we reach loopback 1? It's currently via equal cost path. IS is this loopback is learned via IS across both interfaces. So we load share to 10.10.10.10 load balance, and same for the one inside the VRF. So if we now want to force this one via fast Ethernet 00 and this one via fast Ethernet 10, autoroute announce won't do the trick, because autoroute announce will cause everything learned via IGP from that tunnel destination to go via the tunnel. Just to prove, now do a show IP ceph, we'll see I'll send it via tunnel 0 as well as tunnel 1, because I learned this route, or the next hop BGP, the BGP next hop in ISIs via both interfaces. So we can't use that, but as we know, there's multiple ways to force traffic down a tunnel. For instance, policy routing, setting up forwarding adjacency, and even static routes. So if we now go and say I will get to 21, 21, 21, 21 on tunnel 0 and 22 on tunnel 1, then all of a sudden this guy will follow tunnel 1 and the VRF VPNv4 route, the IPv4 will follow tunnel 0, which we routed because we routed the IPv4 BGP next hop via tunnel 0 and the VPNv4 BGP loopback via tunnel 1. So to test this, we can go clear counters and we can ping 10, 10, 10, 10 in IPv4. Let's repeat this 100 times. And if we now do a show interface fast Ethernet 0, 0 and go packets out, we'll see there's 116 packets that went out there and 10 only had 60. Now if we do the same command but ping inside the VRF, we should see this one stayed in the hundreds, but 10 now also increased from 16 to 128. So we know IPv4 traffic goes via the one, VPNv4 traffic goes via the other, but it's only possible because we forced traffic towards each BGP next hop via different tunnels.